Hi all, Dr. Clark here again. Today for natural resources, we're going to talk about solar energy. Alright, so we left off, we kind of talked about an overview of renewable resources, and we talked about how even if we don't switch completely to renewable resources right now, today, we can still do something by decreasing our consumption rate or changing our consumption rate so oil, natural gas, coal can last even longer. Okay, so we know that non-renewable resources have a life expectancy. They're going to run out eventually. We're going to talk about energy sources, renewable resources, that yes, eventually they will end. So eventually the sun will burn out. Okay? But the last estimate that I saw was probably 1.5 billion years from now. Um, so since humans and our species similar to us, like Neanderthals, Homo erectus, Homo habilis, since none of them even lasted a million years on the planet, I don't think we have much to worry about. So at any rate, we're going to talk about solar energy, and we're going to talk about, in some cases, how it compares to fossil fuels, but also what solar energy is and how we go about capturing solar energy. So I stole this from Energy Seg, and in the best case scenario, with the lowest prices, solar can compete and outcompete fossil fuels. Okay? Now, that is if the system is in place. So you put your solar panels out, you have a system, you have an electrical grid, okay? And then after that, maintenance is pretty low, the overall cost is pretty low, you're not digging more fossil fuels out of the ground or sucking more fossil fuels out of the ground, and so you're just passively absorbing energy from the sun. Okay? And so you can see that it's about 3 cents or so kilowatts per hour versus 5 cents kilowatts per hour, okay, for fossil fuels. Now this is best case for both systems. Okay? So solar is a viable resource in competition with fossil fuels, and we'll talk more about that as we progress. All right, so we know this, that solar energy is far more vast than any other type of energy we have. Okay? When you look at it, and we just look at how much solar energy is arriving, okay, to the atmosphere, it's about 1,330 watts per square meter. Okay? This is a huge amount of energy. Now, clearly, we cannot capture all that energy. It's not possible. Okay? But it is a large amount of energy, and it's constant, right? As long as the sun is there. The amount of energy that reaches the Earth's surface is about 10,000 times more than all the energy used annually worldwide. So if we take all the kilowatts of energy that the entire planet uses, the amount of energy that's hitting the surface, okay, is about 10,000 times that. Okay. With good solar practices, knowing this information, it's quite possible that other countries, a lot of other countries, okay, could consume the amount of energy that, say, the United States consumes, or China, or Japan, or Europe, countries in Europe. Okay? There's lots of other countries that we're considered developing countries that could make it to our level, okay, and consume the amount of energy that we do, okay, because of that surplus of energy. But it really wasn't until kind of the 1960s that we were able to capture or devise a way to capture this energy. Now, plants have been capturing this energy for hundreds of millions of years. Just humans, it's been 40, 50 years that we've been capturing solar energy in the way that most of you are fairly common knowledge, in the way of solar panels, photovoltaic cells, these kind of things. Okay? So if we look at solar radiation that's coming in, and you can see even in the regions that are not next to the equator, you're still looking at somewhere around 800 kilowatts per meter per year. Okay? It's still quite a bit of energy. Now, the problem with regions next to the poles is they'll have periods of time where the sun is not out for very long, okay? And so they have long periods of darkness, and that clearly would mean that the energy source is not stable in those regions. So will solar replace all energy sources? Probably not, but it is quite possible if the grid for solar can move north or south, right, off the equator, that these regions like Alaska and Siberia and things like that, Greenland, Iceland, those regions could get solar energy, but they're getting solar energy from places on the equator. Right? And that's quite possible that they're not creating their own energy, but rather they're buying their energy from countries on the equator. All right, so solar can be collected in two main ways. Passive collection means that you just sit back and allow it to occur, or active, which means that some energy has to be utilized in order to start the collection process or continue the collection process. Okay. Now, we've known for a long time that you can use passive solar energy to heat water or to absorb and utilize it as an energy source, because we've had greenhouses for a long period of time, and greenhouses heat up and when the sun's out, cool down when it's not. And people have taken advantage of greenhouse designs. They've designed houses to have greenhouses to absorb that heat. Lots of things. I mean, you can look on old houses, and in the 70s, it was really common to have, especially in sunny regions, to have a solar panel looking object on the roof of a house, which was used to heat the hot water heater, or to use to heat hot water. Okay, and so that was still a passive solar system. An active solar heat system, okay, is going to use a pumping action. So pumping different materials. Sometimes this will be like a salt system or a salt solution, something that's going to allow for heat to be captured, or in some cases electrons to be captured, okay? And it can be passed then to other objects, or in some cases it can be passed to batteries to charge the batteries. Okay? But an active solar system will often involve some kind of pumping action. So you're pumping material from one region to the next, okay, and that will drive the system. Okay. Now, we've been doing this for a long time. Okay? In the case of, using flat panel solar systems to heat hot water tanks, okay, in which the water is being circulated, okay, through a pumping action. In places like China, this is pretty much the only thing they have is solar water heaters. They don't use gas water heaters like we do in the United States, or electric water heaters and things like that. They use purely solar water heaters. The other thing with active solar is that you can have active solar, meaning that the panels will track the sun. So some of the energy, so if we're not talking about heating water, but we're talking about capturing or producing electrons, some of the energy that is produced will be used to rotate the panels to follow the sun. Okay? And we'll talk about situations where that's the case. All right, parabolic mirrors, okay, have been used for a little bit of time. They're not super common in the United States. Some other countries are utilizing them a lot more than the United States are. But a parabolic mirror is a curved mirror that reflects photons to a central point. Okay? And I'll show you a picture of this. But it's a bunch of mirrors that are reflecting photons to one central point. And there's two techniques to absorb this energy. You can use long curved mirrors, which are reflecting photons to a central tube, and then that tube would absorb the heat, okay? And then you can transfer that heat either as energy, in some cases that's how it's transferred, or you can use that heat to heat a building or a house, or something like that. Okay. The other thing that can occur is you can have a whole series of very small mirrors, relatively small, okay, which are concentrating photons on a central part, like a tower, and I'll show you a picture of this. And then that tower would heat a liquid which would drive a steam engine, just like you would expect if you're just burning coal or natural gas or oil. You're going to create steam, you're going to run a turbine, and you're going to get your electricity from that. You can do the same thing with solar, okay, just by concentrating the photons to heat a solution to make it go into steam, okay, or vapor, and then spin a turbine and create energy. So here you can see this is often called a solar valley, okay, but these solar panels are used to heat water. So in this case, it's heating water for this building. Okay. Here you can see those mirrors that are going to be reflecting light into the tower to heat this solution, okay, produce steam, run the turbine, create electricity. Okay. And so the only solar power tower like that, the one that was shown, you'll probably see that picture if you Google solar power towers, because there's only one in the United States, and that's in Southern California. And currently, under its normal running procedure, normal running process, it's creating enough energy to provide electricity for about 5,000 homes. Okay. And the cost to run that system is far below, okay, not half of oil, but more like a tenth of what oil or nuclear power would cost to do the same 5,000 homes. Okay, so it's highly efficient, although you can see that if we flip back, it takes up quite a bit of land, okay? And it's not as efficient as like a solar panel farm. But this system was kind of the original system that we used to create electricity when solar first started out. So again, these are not solar panels around here. These are mirrors. Okay? The mirrors are reflecting photons to the tower, which is absorbing that energy, the light energy, and creating steam. And I don't know, maybe you can see a little bit of a haze around the tower, but that's the steam that's coming off the tower. Um, and again, this system is okay. I mean, it's far better than burning oil or natural gas or nuclear, but the system is using water. Okay? This is a giant water tank here, okay? And this system uses water to drive the turbine. When we talk about places like California or really anywhere in the Southwest and having shortages of water, you don't really want to use water to generate your electricity if you don't have to. And that's why modern solar, which we will talk about here in a second, is better. It's better than these solar powered towers because there's no water that's involved in the generation of electricity. When we look at what we have in just the United States, we're talking about southwestern United States, the desert, so we'll talk about the Mojave Desert, the Chihuahuan Desert, Sonoran Desert, Great Basin Desert, okay? These four main deserts that we have, right? When you go to the World Watch Institute, they estimate that the United States, just the deserts in the United States, could produce about 7,000 gigawatts of solar energy. Okay? That is 7 times what we currently use from all sources. Okay? So if you take all natural gas, all oil, all hydro, all everything, okay, it's 7 times what we currently use in the United States. Well, based on those numbers, you could see that maybe we should start placing solar energy in our deserts. Okay? 7 times is a great deal because there are still regions in the United States that want to develop, that want to grow, and in some cases it's an energy shortage, or at least high energy prices that might be preventing them from growing in those regions. And as you can imagine, as technology moves on, we use more energy today than we did a year ago, and more energy a year ago than we did, the year before, and on and on and on. Well, it's not like we're cutting back on the amount of energy we're using. We have far more electronics and far more energy consuming products. And so, something like solar in the desert could really offset that advancement that we're seeing in technology and energy use if we were to develop there. Okay, how would we develop? We'd develop most likely with a system using photovoltaic cells. Okay? Now these cells are not utilizing water, and it's not utilizing a mirror, but rather the photons are being absorbed, they're exciting electrons, and then the electrons are moving through or creating a current. Okay? And so you get this flow of electrons, much like you would see in something like a plant, and that indeed is where this technology really comes from, is the process by which we see plants doing photosynthesis. We developed a way in which we, humans can devise a system that basically works just like a plant. Capture photons, excite electrons, move those electrons, utilize those electrons, but the electrons are not being consumed, they're being reallocated afterwards. Okay? And so capturing solar energy now is far more efficient than what it ever has been. Okay? And in some cases, we have efficiencies in laboratories of of new photovoltaic cells that are somewhere around 75, close to 80% efficiency on capturing photons. That's amazing. I mean, if you think about your car that you drive, unless you're driving an electric car, okay, the car that you drive, its engine efficiency is at best 25%. Okay, so when you're burning gasoline or diesel, it doesn't make a difference. Okay, your engine's efficiency is probably at best 25%. I think the highest on the market is somewhere around 28%. Okay? So your efficiency in your vehicle is horrible. Okay? So when we say that the efficiency of photovoltaic cells is somewhere around even 30%, once it's set up and put out on the surface, okay, and they're somewhere around 33, 35%, hey, that's close to 10% better than what you're getting in the engine of your vehicle, okay? And it's free. The sunlight is free. You're not getting charged for those electrons. Okay? But at any rate, we'll come back and we'll talk more about those systems. Okay? So when we look at the past 25 years, the efficiency has changed a great deal. Right? When photovoltaic cells were first introduced, they were getting somewhere close to 0.5%, maybe 1% best. Okay? This was in the 60s, and this is why a lot of people were like, it's just not worth it. The price to build them, the amount of energy that's captured is just not worth it. Recent, okay, in the field, under field conditions, meaning we're talking about an entire year of cloud cover, rain, snow, these kind of things, you're getting at least 15%. Okay? There is no photovoltaic cells out there that are modern that are getting less than 15%. Okay? In the laboratory, under good conditions, okay, they're getting, like I said, somewhere between 75%, 80%. And they're getting better. The modern technology is even better than this. Now, when we look at research experts, okay, that suggest or have suggested that by 2020, so roughly a year, 2 years, okay, the cost for solar, okay, this includes setup, okay, this includes the construction of the material, things like that, just like you would say fossil fuels is going to include the trucking, it's going to include the extraction, things like that. The only thing that fossil fuel doesn't typically include is cleanup cost. So that's not included in the amount per kilowatt. But, we're not going to talk about solar cleanup costs either, because there would be eventually a cleanup cost for solar. You would have to dispose of old solar panels. But the cost would be at about 10 cents per kilowatt. Okay? Currently, it is 10 cents per kilowatt. Okay? So according to most research experts, by 2020, but we've beat that. Okay? This year, right now, okay, it is 10 cents per kilowatt for solar. For wind, we can get 3 cents per kilowatt, depending on where the turbines are set up. Okay? And, fossil fuels really depends on the market. It depends on, what the price of a barrel of oil is, etc. So fossil fuels at sometimes could be 8 cents, but other times, we're talking 20 cents, 25 cents even. Okay? So the one thing about solar, and this is unless certain certain industries get a hold of this and start changing the way it works, but solar is pretty consistent over the year. Your kilowatts, or the amount of kilowatts per hour, is pretty consistent. Now it's going to change because we have winter in North America, so the amount of sunlight changes, the hours of sunlight changes. But really, For most systems, you don't need 8 hours of sun. Right? 3 hours of sun is perfectly fine, um, and that will run the entire system and get you a 10 cent per kilowatt hour. Right? So one thing that we had talked about before is developing countries, is countries that have a large amount of poverty, a large amount of famines, these kind of things. Well, one way that we could probably assist with some of these situations is by providing energy resources for the billions of people that have no electricity. Okay, remember, the world's population is about 7.7 billion people, and 2 billion people out of that 7 billion live without electricity. Okay? Now, I don't think anyone in the United States, I mean, the last time we had a huge power outage and it lasted a week or even 2 weeks, okay, people were dying all over the place. Okay? That can't happen in the United States. We can't have long periods of time without electricity, okay? Because we live in colder environments. Most of the people that don't have electricity live in warmer environments, so they seem to be able to at least cope with it. However, the electricity is not just for heat and cooling. It could be for lots of things. Technology advances, okay? Running pumps so they don't have to pump water by hand. All kinds of things, that can make the life of individuals in developing countries better utilizing electricity. Just a light bulb, so you can, move throughout your house without, bumping into things, or an electric stove so you can cook food versus utilizing fire and things like that. There's lots of ways that can make some of these billions of people um, more developed by utilizing just some photovoltaic cells, which are fairly cheap actually. Now, I had you guys talk about or look at a discussion post on Tesla and their roofing tiles. There are a lot of other companies, okay? A lot of you suggested, that it's too expensive, these kind of things. Well, expense is, it's part of the game. Okay? Most companies that come up with a new technology will make it expensive. Other companies are moving into the photovoltaic roofing tiles, and you're going to start to see that this market is probably in many regions going to replace the normal roofing tile, especially as prices get a little bit cheaper. But there's a lot of new technology out there, not just the roofing tiles, which makes them flexible, okay, but the amphiferous silicone collectors. Okay, these have allowed for the tile itself to be lighter, okay, more streamlined, and decreases cost. And we've already talked about this. You already watched a video on this. For the most part, you can set, roofing tiles on the south-facing side of your house and generate plenty of electricity for that home. And in many cases, you'd create a excess amount of electricity, which could go back into the grid for regions that don't have the amount of sunlight that you would need to create a large amount of electricity. Right. Now, part of the process by which we can shift and move into solar really has to do with promoting renewable energy and renewable energy usage. I'll tell you, for example, in Wyoming, if you were to set up solar on your house and you created more electricity than you could use, you can run what we call run the meter backwards, which means that the electric company, whichever electric company you're under, is obligated under Wyoming law to pay you. But the caveat with that is they pay you whatever they feel is the fair value, which is not what they would charge you for a kilowatt hour. Okay? So they're going to charge you a certain amount per kilowatt hour, but if you create more, they're not going to pay you the same amount that they would charge you for per kilowatt hour. Okay? So in some cases, by doing things like that, by having statutes and things like that, it doesn't benefit the individual to go out and, make the shift, change to solar, because the electric company it's not paying you what you earn. Okay? Other states, they pay you the exact same amount. They pay you the same amount that they would charge you. Okay? And in many cases, that's why people will go solar, is because if you're going to add to the grid, then you should be compensated for that because it costs you to create the energy. Okay? And it should be a fair compensation. Okay? But in some states, that fair compensation it doesn't come to play. And so really an individual who would choose to go solar would do it just for the environmental factor. Okay? And the fact that they would not have a power bill because, yes, the electric company might pay you pennies on the dollar, but at least you still would not be paying for electricity. You created your own. Okay? There are lots of other ways that can promote renewable energy, but also other ways that can kind of hamper or dissolve renewable energy. Okay? So distributional surcharges, these can be small fees on utility consumers to finance renewable energy. Okay? So you can get these small fees from electrical companies that you can buy in, and you can say, all right, well, I want this % of my energy to be renewable. Okay? So basically they charge you a little bit more money for it to be renewable. But as you can see before when I was showing you fossil fuels versus solar, solar's cheaper than fossil fuels. So why you would be getting charged a small fee, beyond me. There are some states, though, and many countries that have a different program where renewable has to be a certain % of your power that you're getting for your house or whatever it might be. It has to come, a certain % has to come from renewable resources. Okay? And you can see, like, you'll hear often, like, California wants to go 50% renewable by 2020. Okay? So if it becomes part of a statute or part of, some kind of act, law, Congress, whatever it might be in the United States or state statutes, these kind of things, you can have this as part of the premise in living in that region. You must have 25% renewable. And that way, if people live in small towns and things like that, that small town will have to come up with a renewable resource that provides 25% to their citizens. Okay? And that's why some places have done this. There's whole countries that have done this. Sweden, Costa Rica, okay, and they just said, look, we are going 100% renewable by this time period, and no one can deviate from that. Otherwise, you will be penalized. Otherwise, you will pay a fine. So if you're not using renewable resources by that point in time, you're going to pay the fine for not using them. Versus, some other situations where we have green pricing. So You might have situations where you're actually charged a premium for renewable energy. Now, in some cases, it could be less, but in many cases, it's more. Okay? That extra money, in hopes, a lot of times it depends, but that extra money will sometimes go to conservation programs. Okay? So you might say, hey, I want 50% of my energy to come from solar, and they're going to say, okay, well, 10% of that bill is going to go to a conservation program, like buying up habitat for animals or different things. Okay? And there are some green pricings that way. Okay? Other times, not as much of the profit will go to conservation programs. So if you're in a situation where your electrical company gives you green pricing, make sure you know what is moving to the conservation programs. How much profit? The excess profit, the more money that you're paying versus someone who doesn't choose renewable resources or renewable energy. Is that all going to a conservation program, or is just a really small amount, like 5% of the profit going? Okay? I would check it out before I join one of those programs. Okay? Probably the best thing to come to market is this system that's being promoted by companies like Tesla, and that is the smart metering system. Okay? And that would be to buy a hybrid, okay, an electrical car, so not necessarily a hybrid, but an electrical car or a plug-in hybrid, okay, and create solar at the house so that surplus energy can go into recharging the battery of your vehicle. So you're going to store energy in your vehicle's battery overnight or in the evening time, and then you're going to utilize the energy during the day. So you would have to have a system in which you have a battery system which is going to absorb energy during the day, stored in batteries, and then it can transfer into your vehicle. Okay? So then the battery system can recharge during the day. So while you're driving your vehicle around, your battery that's maybe in your garage or whatnot is being charged to resupply your vehicle for your next trip or whatever it might be. And so this is this is definitely the system that companies like Tesla, and now I just heard that GM is getting into this, and Ford is getting into systems like this. They're trying to develop systems in which you can basically charge your battery in your garage and then supply that energy while your car sits at night. Okay? The other thing is we're starting to develop smarter appliances that have the capability of consuming energy during non-peak times, so during the night, and then so they're running at night, or they're utilizing the energy during night and maybe storing it in a battery to run it during the day. We've been doing this for a long time. The green movement of the 60s and 70s, there was a lot of flyers that would say, wash your laundry at night. Okay? Only use your wash machine at night. These kind of things. And it was really, or your dryer mainly, but it was really around this night consumption is lower. Okay? So utilize the energy during the nighttime. Okay, so with that, we're going to move and we're going to talk about wind, and then I'll talk about geothermal and a few of the other renewable resources that are less common.